Very good. Hello, how are you? Welcome to the session, Building Resilient Systems with Spring Cloud Contract and Testcontainers. Initially, the session was called Stop Breaking Things All the Time, but then we decided that we need to be more professional in how we express ourselves. So, welcome. No, this is right.
Yep.
What's going to happen in this session? We're going to talk about a particular setup. We're going to talk about contract tests, which is a very useful thing and a type of test when you deal with systems of microservices or any services that talk to other applications, either via REST or through message brokers or anyhow. We're going to look at two libraries that simplify your setup for the contract tests, which is the Spring Cloud Contract and Testcontainers. We're going to look at an example of an example project with two microservices talking via Kafka, and we're gonna learn things hopefully. So, without further ado,
Yep.
please welcome.
I work on the Spring Cloud team. My name is Olga Maciaszek-Sharma. I mostly maintain the load balancer, OpenFane, and Spring Cloud Netflix, and also have been adding native support for Spring Cloud projects and been involved in Spring interface clients. But much before all that, I've been the first, other than the two maintainers, the first contributor of Spring Cloud Contract and probably the first user. So yeah, I hopefully will be able to show you some things in the project.
Right. So Olga is obviously the expert for contract tests and the Spring Cloud Contract. And my name is Oleg. I work at the Atomic Jar company, and we maintain the Testcontainers libraries. I'm a developer advocate, so my contribution list is way smaller, but I'll be responsible for the jokes and the comedic relief for the session.
And the Testcontainer setup.
And the Testcontainers parts as well, of course. Our project, our sample project here is a coffee serving application. There are two microservices, a waiter and a barista, which is the server, and they communicate via Kafka. The waiter offers the HTTP endpoints for ordering coffees and then sends messages to Kafka. The barista gets the messages from Kafka, produces the coffee, and puts the coffee messages back.
Coffee servings.
Coffee servings back into Kafka. So specifically, we wanted to make this example project using the message broker for communication rather than the what's typically has been done for showing the contract tests, which is the REST communication, where one service calls the other service directly via REST. So we'll have this project. It is available on GitHub.
Yeah, it is.
Publicly available. So if you find Olga's GitHub account /coffee, you can clone it, you can pull it, and you can run the test with us. Right, this one. This is an example of the messages that that those services communicate via. So it's a very simple and very typical setup, right? How do you test things about that? If you're responsible for the waiter microservice, how do you ensure that it properly communicates with the barista? If you are responsible for the barista service, how do you know that while evolving it or implementing whatever changes and bug fixes, that you don't break your clients and that the whole setup works together? Normally, the situation is very simple. You talk to the teams who maintain those other services, whether this is you or yourself or your colleagues or some other department that you secretly hate. But you talk, you discuss, you finalize sort of the protocol for the message. You put this JSON file example somewhere into the knowledge base or your Confluence or your wiki, and then you implement the stubs, like the mock implementations that sort of return that JSON, and then it all works, right? You test it, you get the messages back, you send the messages, all is peachy, and then you deploy it into production.
What can go wrong?
And nothing can go wrong, but it always does. It always does. And there are multiple ways how things could go wrong, even at a very simple setup where two services exchange just a single sort of type of a message.
Yeah, so the main problem is that basically people talk and say various things, but in human communication, or even, who would believe it, even in documentation, people make typos, people write strange things, people have bad days, and if we do not verify something and automate something, random things happen. So what could go wrong? For example, the topic here is servings, where we are sending our messages. But I have seen similar situations just before deploying to production where the topic differs by one letter.
I did this. This was when we were preparing the demo. I was going into the URL with orders, and it's actually /order, singular.
It happens all the time.
And my test didn't work. I was furious. And then I checked my typos.
Yep. And similarly with POJOs, yes, that we used to serialize and deserialize stuff for our messages. Sometimes it's an ID, but somebody will think it was a product ID, a UID, whatever. In our case, it was a UID, and we can, by mistake, put ID there. And another thing is headers. We can have some standard ones, but we also can have some custom ones that we actually need to be correct in order to be able to process stuff correctly later on. And again, something can go very much wrong here. And the problem is that the same team is writing these stubs and then testing their own system against these stubs.
Yeah. It's sort of when you have to have a different mindset when you write the tests compared to the mindset when you write the actual code, right? When you are responsible for implementing the sort of the stub for the project, you want, as a developer, like in my experience being a developer, like I was very lazy. The lazier I can be, the better. Like laziness is the virtue. So if I can get away with cutting corners, I would. So if I have the stubs that's sort of supposed to work, I will just write the code that works with them and be done.
Yeah, there's this confirmation bias also, like your mind wants you to confirm that you were right.
You run your tests against this implementation that you wrote yourself, and they pass, and everyone else is at fault, right? It's never you. So it's never enough, and what's the right approach?
Yeah, so stubs alone are unfortunately just wishful thinking, and we should have some kind of automation model in place to verify that these stubs are in keeping with the actual producer app, so whatever is sending us messages or whatever is exposing some kind of endpoints. And one of the approaches that has been discussed since a very long time, but has been implemented for a much shorter time, are consumer-driven contracts. And one implementation that we'll be talking about is obviously, it's a Spring conference. We will be talking about Spring Cloud Contract. And Spring Cloud Contract supports REST, but it also supports messaging. And while with HTTP, it was quite easy for us to use always just WireMock as our one dedicated tool, for example, for loading and running the stubs. The problem began with messaging, and also on the producer side. For example, you could use there were some kind of like mocked stubbed solutions, let's say for AMQP, you could have some embedded solutions, and so on. But we were actually getting issues from people, and sometimes things would behave differently during the contract test and differently later on. So this was something that we wanted to avoid at all costs, and we wanted a solution that would be easier to maintain for us and at the same time better to verify stuff for the users. So now a Spring Cloud Contract also, and actually only, uses the test container setup instead of things like embedded solutions or like stubbed AMQP and so on. And it's very easy for the users because, as we will show, they will just need to run a container. So in this case, it's going to be a Kafka setup, so just Kafka container, and they can test everything. So it's easier for the users, and it's easier for us.
Very good. So there are a number of concepts that we need to sort of be aware of, because we're going to talk about them, right? So, and I would like to highlight the names of them, so you understand kind of sort of the picture that we're going to talk about without going further into details, and then we're going to look at the implementation of those things. But here's the sort of the mind map. First, for the Spring Cloud contract setup, you will need to instrument your project with the plugin. The project will generate you some tests on the producer side, for example, so it will need to work from your build tool. So there is a build tool plugin that we're going to do. You will need to specify the contract definitions, which is how you document what the API is supposed to do. And there is different formats for that. We're going to look at some examples, but you need to have the definition, which is the source of truth, what the API should be doing. And you will also need to create the setup for running your tests, because they could be different. You, as a developer, know exactly what you want your setup to look like, so you need to provide that to that build tool to generate you the tests automatically. When you have those three things, which are the inputs for the setup, what it will happen, you will run that build tool plugin, and it will consume the definitions and the setup configuration, and it will produce you with the generated tests for the producer. So the tests will be automatically generated, and the producer code will be verified whether the actual API that it offers conforms to the contract definitions that we feed into it. And when the generated tests on the producer side pass, then the stubs are generated for you automatically. And you can use those stubs on the other side, on the consumer, to verify that the consumer works with the particular implementation of the producer. It's a little bit like that's many moving parts, but you have the inputs, which is the configuration to fix the producer, and then the tests, and then the stubs. So how does it look like?
Yeah, so let's see this in code. Let's see our Barista app. And as we have seen, we have some kind of handlers for our Kafka. So we have some methods that will listen to things happening in Kafka, get orders, and transform them in coffee servings.
Yeah, perfect setup.
Yeah. OK, and then we want to be able to produce stubs and to have generated contract texts in this project. So as Oleg said, first we need to set up our build. In this case, we will need to add, because it's a Maven build, so we need to add the Spring Cloud Contract Maven plugin. We obviously also provide solutions for Gradle.
Do you have the SBT?
Marcin, is this a problem for us?
Yes.
Yes. OK. So we have to add this plugin. And then we can configure stuff. For example, we can set the testing framework. So here we have JUnit 5. And we have also set our base test class. So as Oleg said, other than configuring the build, we need to configure our test to do some initial setup for the system to know what it is doing. So first of all, since this is messaging, we need a messaging broker. And here's where we use the Testcontainers. So we just add our annotation, we create a container, a new Kafka container, which, as you can see, is incredibly easy. And this is something nice, but we'll go back to this in a moment.
Yep.
The service connection annotation. And what we need to do is tell our system how to send messages for these tests. So what we want to do is use production methods, so the process method that I am actually using in my production code. But the data, the test data, I just need to generate it somehow, because I don't really care about these inputs. It's just for this something to happen, and then what we want to verify is the outputs, not the inputs. So as in any test, I have some kind of given section, and this would be part of my given section. So I want to create a coffee order that normally I'll get somewhere. And then I want to use the same method that I'm using in production to process this order and to create some objects and send messages containing them. And we will be testing 2 scenarios in this demo. We have one which is positive, so we managed to make coffee. And we have another one where something has gone very wrong. And yeah, we do not actually have a coffee matching that name. And then we will also need to, but actually you will not need to, so we need it to. And I will tell you how in a moment. Implement interfaces to tell contract how to get messages from Kafka, because as we've said, we could have different message brokers, different setups, and contract doesn't know the internals of them. So we need to tell how to receive these messages and how to be able to process these messages. So for example, for Kafka, we would do this with a listener. So we create a listener, and then we are using, just for this demo implementation, a blocking queue to put the messages from there, and that's where contract knows that the messages are. So it will try to get them from that blocking queue. And this is something that's a bit tedious to implement for everyone, because it will mostly be the same. So what we've done for now is put it in a, this we've seen. We have put it in a sample project, and you have all these implementations for the different brokers there, and you can just pretty much copy-paste them. We do have an issue to create auto-configurations with them, so this might also happen, and then you don't even have to do that, unless you have some super custom scenario, and then you have the liberty to implement them yourself.
Right. So to summarize, let me go back for a second. Right, to summarize, you need to add your build plugin into your build tool to configure that you want to generate the tests, and you need to configure the base class, which will do the following things. It will set up the environment, your broker, for example. It will create the inputs to poke the producer, and it will verify it will not verify the outputs, it will provide the plumbing to understand how to get the outputs out of the producer, to verify them automatically against the contract.
The framework will verify the outputs, which we'll see in a second.
Yeah. So you just only need to provide this for the current setup, how the generated tests can get the outputs out of Kafka broker, which you do by exactly copying the sample for the messages, right? You create this setup, and you create your brokers using the Testcontainers libraries. Spring and Spring Boot has an excellent integration with Testcontainers, which in the current release got even better. But in a nutshell, Testcontainers provides you with programmatic API to create services running in containers. You can create, instantiate, configure, manage, run them, stop them, do anything that you want via the API calls. So it sort of provides you with dependencies, service dependencies as code, which is extremely, extremely convenient for us here, because we can create a Kafka broker with just a single line of code saying, give me a new Kafka container. And this is not just Kafka or the databases. There is the whole ecosystem of modules available for Testcontainers. So if your message broker is, for example...
Yeah, if it were RabbitMQ, could we set it up?
Yeah, if it would be a RabbitMQ, we would have a different Testcontainers library as a dependency. And then instead of saying like the Kafka container, we would create the RabbitMQ container, or the HiveMQ container, or whatever other things that you need to, which is extremely, extremely useful. So the only part that we didn't cover out of the inputs that we need to have is the, the contract definitions.
Yep, the contracts. So we've already seen the message that we would be sending, more or less what it looks like in the slides, or even precisely what it looks like. And then when we are in our barista again, it's very easy in source test resources, by default under contracts, we can place our contracts. So as we've said, we'll be handling 2 scenarios. So one is positive, when we can create a serving, so we have to verify if our system sends a correct serving message. So we will obviously need to have the message, so we need to know the topic, and then we need to know how to verify the body, because the verifier tests will do exactly that. We'll try to see the body and then check if it's right. How does it know if it's right? We need to tell it what criteria it has to match, so what fields it has to have. But also, for example, there are situations where we want a field to be a certain type or in a certain format. We don't necessarily want to specify it or even can specify it because our system assigns something randomly, for example, UUID, or it's a date that changes. So there's plenty of utility methods in Spring Cloud Contract that you can use, and here I'm using any UID. But as you can see, there are lots of them, any URL, any date, date time. There's a lot to choose from for whatever scenario you have. And we also want to tell which headers it should have. And again, we have lots of utility methods. For example, you don't need to type it all on your own. So IDE will help you, and you can just use, say, application JSON. And then you can also use a header method to show your own custom headers, to add your own custom headers if you want to. And what we also need to have is say what is our input. So here we specify one of these methods that we had in the base test class where we were teaching the system, okay, take these inputs and run our production method, and that's how you will trigger a serving or create a message for the serving. And we will also have a label which will allow us on the other side where we want to use this stub in the consumer to know which stub we are looking for. And then...
Do I have to use Groovy?
No. You can also use Java. Okay. You can also use Kotlin. And if you very much want to, you can even use YAML.
No.
No. So yeah. We also have here a similar situation, our opposite scenario, where we want something to be sent to the errors topic because something went wrong for us. So yeah, we have the contracts now. Should we see what happens with the contracts?
Yeah, I think so.
Okay, yeah, let's try.
Wait,
let's see.
You're running already? I thought we need to generate the tests.
Yeah, but I don't think I need to generate the tests.
Okay, so you're generating and running the tests at the same time.
And testing at the same time.
How bold of you. So the build plugin
let's pray to the demo gods.
To generate the
okay,
tests.
Something is happening. Can you see there is a message being sent?
Do you think it will work? No. Who thinks it will work?
Then we're waiting.
Who thinks it will not work?
Okay, first, about the wait, there is a timeout in that sample setup that you can copy-paste, and you can adjust the timeout. So now you don't need to do all that wait. But basically, we have an error, and that's why the wait is there, because we keep trying to receive a message, but the message is not there. And now we will see why it's not there.
Can I run my contract test from the IDE?
You can run it, yeah, but first you need to create it. So the first build you will usually need from Maven anyway, or Gradle, but then yeah, you can run them in the IDE. So it says that basically an NP, there was no message, and it's the contract verifier test that is saying this to us, and we did not write a contract verifier test. We just put a base test class. So where did this come from? Something was wrong. Or yeah, but first let's even see what this test is doing there.
Yeah,
like
exactly.
I haven't added this test. So as we can see, if we go under in Maven, our target, and we go to generated test sources, this is the test that the framework has generated based on the contracts that we provided to it. And for some reason, it is not getting any messages on the errors topic. So let's go back to our production code and see what happens. So yeah, obviously for this demo, we have broken it a bit just to show you that we are just not trying to sell you something which doesn't do anything. It does do something. So yeah, the test was generated, not by us. The code was wrong. The test failed. I think that's a good thing. And let's try to
clean install.
Yeah, thing again.
So now it will regenerate the tests and run them again. And now hopefully we fix the issue with the producer. So it will also correctly send the error messages.
And it's fine.
And it's fine.
Thanks. And as Oleg suggested, as you are working locally, you don't, like, once you have the contract test and you only want to swap things in your code, and you can rerun the contract test from your IDE. We have a nice integration. It all works like, pretty much seamlessly. Let's go back to that test. As you can see, you can just run it from here. Anyhow, we do have this, and we have one more very important thing here, is it that other than saying that it has installed our artifact, so our Barista app somewhere, wherever we want to install it, in this case, local Maven, but would be something else in deployment pipeline. Other than that jar, it has also installed this stubs jar. And this is where our stubs are, and now our consumer applications will be able to use these stubs knowing that these are actually verified stubs and no longer any wishful thinking. Okay.
Right. So we generated, we verified, we provided the contract, we generated the tests, we looked at the tests, we ran the tests, and when the test passed, we got the stubs, which are the programs which are mimicking the actual producer API. So what we're going to do with those, we're going to use them on the consumer side to run our tests against that, verifying that not only, like on the producer side, the API produces what it's supposed to, but also as a consumer, we can work with that and work with that protocol.
Yeah, that's basically what we want to have at the end of this. We want to have stubs that are according to the producer and that are not our wild imaginations. Yeah, one question that we sometimes get, what is the difference between contracts and schemas? So first of all, contracts are scenario-based. So as a consumer, I only want a contract that has the fields that I'm using. I don't really care if other consumers are using any other fields. At the same time, as the producer, I see different contracts that I have for different consumers, and I know how they are using my API. And this is very useful because sometimes it can appear that only like one consumer is using something that we want to deprecate or remove, or even that nobody is using that anymore. So why are we maintaining a whole functionality or whatever? So it's very useful. And the second thing is that through this process, we do get the stubs. So we can do the integration testing on the other side. It is not just a registry of some kind of definitions. It's a very active testing support.
All right. OK, so let's look at the other side then.
Yep.
So we looked at the Barista application. Okay?
Yep.
OK.
Yep, that's yours.
Right. We looked at the scroll direction is different. We looked at the Barista application before.
On the Mac, it's strange.
So now we have the waiter application. It's also a Spring application, right? And it's also, where's the, what it does, it binds at the HTTP, and it can request the things, and then sends the messages to Kafka, which will hopefully picked up by the Barista application, and then on the other side, they will come back with the servings. And the serving is, where's the serving? Wait, orders here?
Yeah, here's the serving.
No, where's the listener?
Wrong. OK, it's in the waiter app.
Yeah, it's right here. Sorry. Yeah, my bad. So right here in the waiter app, we listen to the servings and the errors, and then we log them. This is our whole business logic for the simplicity, but it shows the whole sort of round trip to Kafka and back. Now we would like to use the contract tests
and the generated stubs.
And the generated stubs in our consumer integration tests. We don't call them the contract API tests, because we don't.
Well, actually, the API is tested on the producer side.
Yes.
And here we have an integration test where we want to be able to use stubs that are valid and tested.
Exactly.
And nice.
So here we just verify that we can work with this, but there is no contract being used directly in the consumer tests. So there is a normal integration test, and this is a normal, can you move this way?
Yep, sure.
A normal Spring Boot test. We would generate some test. We will auto-wire the stub trigger, which is the trigger for the stubs that were generated. We're going to use it to send events to imitate the barista actually producing the servings for us.
And this is the label that we had in the contract. So that's how it will know which stub we are looking for.
Yes. And we need to provide our consumer project with the stubs. So the stubs are here. We can configure which group ID we want to use. If you want, we can put the versions in as well. And we also tell our tests where to get the stubs. Currently, we're using the local mode because we just built the barista application and the stubs were installed into our local Maven repository. But you can also put it into the remote mode, and then they're like normal artifacts downloaded from your internal artifact repository, Artifactory or
wherever you keep them, basically.
Yes, wherever you keep them, they will be downloaded normally. So we run this test, and the test looks like the following. You trigger the serving, and this test currently checks only the sort of the second part of the process, not taking the orders and putting the orders onto the Kafka broker, but receiving only the other part.
We basically check what are we doing with the messages when they have come to us.
Yes. So the back half of the process. So, and it looks like this. We have the stubs. We trigger the stub to produce the messages for us as a barista would, and then we await for the messages to appear, and then we verify our business logic in the application, which is currently that we would have the log output.
Obviously, this is the demo. Normally, you would something more fun than logging.
Yeah.
But
for example, that some information appears in the database or some
something
other
displayed,
side effects that happened, and so on. And the similar setup is with the error, we trigger another stub entry point that we had in the contract under the error message, and then we await that our application correctly processes those messages and logs the correct output. So for this, we are also going to use the actual implementation of the Kafka, because we're going to put messages on it and receive them from that. We're going to use Testcontainers for this with the new integration that came in Spring Boot 3.1. So
this is fun. It was just released yesterday, and we have just updated the code today, and it still works.
I think it propagated to Maven Central like around midnight. This is literally the bleeding edge of development.
We are showing you new stuff.
Right.
Okay.
Oh, sorry. So the containers are defined in the separate test configuration file, and we are getting the Kafka container here. The Kafka container, of course, comes from the Testcontainers library. This is an abstraction that knows how to run Kafka in a Docker. How do I get back?
Different shortcuts.
Very good. Very good. We define it as a bean.
Yeah, why is it not a container only?
So if you used Testcontainers in the past, you also saw annotations like @Testcontainers or @container. Those are for the integration between Testcontainers and JUnit 5. They are processed by the JUnit 5 extension Testcontainers provides, and they tie the lifecycle of the containers to the lifecycle of your JUnit 5 tests. So the containers will be started automatically when in the correct time of the test lifecycle and stopped as well. Here we define this container as a bean, so the lifecycle of this container will be tied to the lifecycle of the Spring context. Spring will know that it deals with a Kafka container, and it will be able to start it correctly. And the important bit is that we use this new service connection annotation, and it will process this Kafka container, and it will know that it deals with Kafka, and it will know how to configure your Spring application to talk to that particular service. So if you would have the bean and the service connection on a, say, a database container like Postgres container, it will configure the necessary database properties like JDBC URL, username, password. For Kafka container, it will configure your Bootstrap server's URL. So with just a few annotations, we can manage the lifecycle of this container, which will spin up the actual instance of Kafka, and we will wire it into our application. So when we run the tests with this configuration, it will create the container, and it will wire it in. So when we send the messages into that, the message will appear, and our listener in our waiter application will receive them. Right?
Yeah.
Can I run this?
It should, hopefully.
How many of you think it will pass? How many of you think it will fail?
Yeah, people of little faith. Let's see. Okay,
I've seen both personally.
Yeah.
So.
And the important
Why
thing
is it
is
not failing? Okay.
Oh, perfect.
Very good.
It passed. Yeah, but before the service connection, you would have to take all these properties that Oleg talked about and use a dynamic property source in Spring to set them in every test, which is not ideal.
Yeah, so before you had to do more manual steps, and currently the integration is much, much tighter, and it allows you to create those complex setups. This wasn't the most complex setup, but very realistic setups, and the complex one for your tests. So here we can run the test. We verify that our waiter application works and can process the messages that barista gives it. And we know that those are the messages the barista gives it because they are auto-generated by the stub, which was verified, which was generated after we ran the contract tests on the producer side and verified that that API responds with that correct
Yeah.
a correct sort of schema of the messages, right? So what else can we do, right? We can also maybe extend this into like a proper or more like a larger integration test to, for example, test more evolved integration test to test the whole round trip of the things. For example, we could use a library like Rest Assured or something to trigger the HTTP request to the waiter application, putting the orders in, waiting for it to receive the order, then triggering the barista response and waiting for the actual application to come back to you with the serving, verifying the whole round trip, which is you might want to do. And this is sort of how you can do it and use the trigger at the appropriate time in your test code to simulate the other part working in your larger scenario. But that's not also all. Besides just being able to run the tests, this new Testcontainers and Spring Boot integration allows us now to enable the same configuration for the local development environment setup, which is like a very interesting thing. I can take my whole containers configuration, and this is the environment that I need to run my application. Right?
Yes, so before Oleg changed that, I had to have a Docker compose and set all these containers on myself just to work locally. Now, we don't need to.
Yeah. Now what I can do, I can create an entry point into my application under the test class path, which will have access both to my main class path files, like the actual application class, but also access to our container configuration and our test containers classes. So I can run this application, and it will run, and it will discover my Docker environment, and it will create the containers configuration declared containers for me, which will start Kafka, and it will have my application running locally, and then what I can do, I can go back to my orders and, for example, send an
order.
Send an order. Let's say Oleg. No, there has to be coffee in it.
Yeah, I think you will get the error message.
That is not true. I don't think we'll get the error message.
Should we add an Oleg coffee to our coffee shop?
Right. So we can. No, it's just like the waiter doesn't verify anything. It just goes to the.
But if you look at the logs, you will see the message in the logs. Anyway.
No, it just puts on Kafka.
Yeah.
Doesn't matter. It's a sample application. It doesn't do error processing. So, but it works. So the request go into the application. The application correctly sends the messages to Kafka. Where's the mouse?
It's here.
The messages to Kafka, and then returns with 201 for us. Is this 201? Yes.
Yeah.
With 201, that the order was created, and then it continues to operate and work normally. So I can do this. There are a little bit more involved setup, but I think it's doable. If you want multiple services to connect to the same message broker instance, it is possible, but it's not very refined at the moment. So if you're interested in that, come see us later.
And if you want to use all these new test containers support for Spring, you will need to add Spring Boot test containers dependency. It will not come automatically in Spring Boot tests. Okay, Linux Magic, let's go back.
Yeah, can you show POM XML?
Yeah, we will do this. POM XML. Okay, and we have it here.
Yeah, so you add a dependency, you slap some annotations, and you are infinitely more productive because you don't need to worry about environments.
Yeah, it's
Congratulations.
fantastic.
Thank you.
I so much hated
you.
have to write these Docker Compose files just to run locally with containers. Now it's just working.
Right, let's go back to from this cool development type stuff to the higher level questions. So now we have an option to generate the contracts and generate the tests for the producer and run them, generate the stubs, and use those stubs in the integration type tests on the consumer side. Can we organize the teamwork around that?
Yeah, because we have the two teams. So let's say the barista team, the waiter team, and again, it's difficult when you have people and not machines to automate things and set up stuff. But there are various approaches, and we would argue that some are better than others. You could have provider contracts where the contracts lie with the producer, and the producer does not have knowledge on how consumers use their API. So it's similar to schema. It can just publish something and be happy and not care what the consumers do with it. And in this kind of approach, the producer can also impose contract changes and API changes on consumers.
This is what we had.
No, we had hopefully the driven one. So this is process. So actually, the code can look the same, but the way we work is different. So we can have consumer contracts where the contracts are also, in this case, are kept with consumers. It can cause issues with conflict resolution when, for example, different consumers want different things in the contract changed. And for some implementations, for example, of contract testing, the consumers can impose contract changes and break the producer, which we may want, we may not want, I wouldn't want, it's up to you. And then we have consumer-driven contracts, where you can also have the contracts, as you've said, with the producer, so similarly to what we have in provider contracts. Or if there are any security issues and you are not allowed to check out code that other teams are working on, you can just have a separate repository that is only for contracts. But what we expect is for the consumers to be key participants all in the process of the creation of the contracts. And it also allows us to easily handle multiple consumers, have knowledge on what multiple consumers are doing and caring about this. So yeah, what does this flow look like? So for us, working in open source, we believe in pull requests. It is a super effective way of collaborating. So we think the best thing is for the consumer to check out the producer code repo and first work locally to design a contract. And why would the consumer be designing the producer API? if you go back to maybe some experience where you worked both on front end and on back end, or on a consumer and producer, and you started working with the producer, I don't know how it turned out for you, but for me, when I did the front end first and then I started working on the back end, it was fine. But when I first did the back end and then I started working on the front end, I realized, why did I create this API? Like, it's so difficult to use, it doesn't help me. So consumers actually consume the API and they can hence create it. So he's happy with his ideas for the new contract, but it's not his repo. He cannot just impose it. So he created a pull request requesting the producer team to please take in the new contract. The producer team can then review the contract, and hopefully some discussion happens. That is when other consumers can also raise issues. This is where we agree on stuff. And again, as consumer, I can propose new contracts, but I'm not imposing them on the producer team. That is also probably protective of its code and its API and doesn't want stuff imposed. And then there is a collaboration happening, some discussion happily. At some point, people are happy, and the producer says, OK, I will go on with this contract. So I have a branch, PR branch, I have a contract, and then I run my production code. And as we have seen in the demo, if the implementation is not there, everything will fail. So has to add required messages, required endpoints, and so on, has to change maybe the body that is sending, whatever, adjust the API to meet the contract. And then they are ready to merge this into their main branch. They can run the build, everything is passing. And then they can also do this in their deployment pipeline. So apart from their normal artifacts, the stubs artifacts are deployed. And then, coming to the consumer teams, they can just use the stub runner to very easily have these stubs searched for them.
Right. So this is when we design the producer and the consumer from scratch, and we can work on that like from the clean slate. How do we handle the situations where we already have the producer and consumer in play, and we want to like move them forward, evolve them, if you will?
Yeah, sure. So we can change stuff in our systems, like it's not a public API, we'll just not publish it and leave it forever and maybe create another version. If it's a vital part of our microservice ecosystem, we will sometimes want to change it. But even if we change it, we still want it to be always backwards compatible, and we do not want to break our consumers. So we would have some contracts added again, but in our pipeline, we could verify two things. First of all, what we've been already verifying, which is how we are working with the current contracts, but we could also include a step in our pipeline to verify if we are also working with a previous version of the contract that our consumers may be using. So in this case, it's very easy to do both in Maven and in Gradle. In Maven, you would just have to set up, for example, different Maven profile, and we specify directly, I want the latest production version, whichever that version will be, of my contracts, and take them from here. So test against that. And that's it, all done.
So I'll just run the tests twice. One with the currently deployed latest version of the contracts, knowing that my next version doesn't break that, and with the latest and all the changes, knowing that I want to move forward, satisfying both the existing clients and the new clients.
And how do we move forward? So let's say we really want to change this API, and we had a UID field, we don't like it anymore for whichever reason, we now really, really want the ID field to be there instead. So we don't want to break anyone. So first, we are just it's similar to what we do with databases, yes? So we first just add the new thing. So we add the new thing, both in our production application and in our contract. Everything works, everything is running. Then we, so the consumers can see the new field and can start adjusting, and some will. And the ones who are kind of more on the reticent side, we do another step. So we remove the old field from our contract, but we still keep it in the app, in the production, so nothing will break. And then the consumers will see that, oh, our tests are failing, we need to adjust. So they will have to do. And once all the pipelines are green, then what can happen is we can finally remove that old field from our production code and hopefully not break anyone.
Right. So that is all sort of most of the things that we wanted to share. What we covered. We covered a sample setup of 2 Spring Boot applications communicating via Kafka, having the Spring contract, cloud contract plugin to generate the automated tests for the producer API, having the stubs that were generated running in the integration tests on the consumer side, specifying the environment with the test containers for providing us with the real instances of Kafka, so all of those parts could communicate together. And Olga shared a little bit of fundamental information about how you can organize the actual communication between the teams and what options are there to set up the development going further, to evolve your projects. There are a number of resources, of course. The application that you have there, where you can run the Maven clean installs, this is on GitHub /Olga/coffee. The documentation for the Spring Cloud contracts are available up there. And if you want to know more about test containers, then testcontainers.com is where you can go. We are at time.
We're out of time, but we are very happy to take questions. So whoever has questions, I think we can answer them in the lobby. Yeah.
We're going to pack very slowly until
Or
they
here
kick us
or
from
there.
stage.
Yes. Yes.
Right. Thank you very much.
Thank you.